Hello and welcome everyone to another episode of Developer Office Hours. I am your host, Ryan Fox. I'm a developer advocate here at Algorand, and I am joined by my colleague, Russ Festino, also same role here. And today we're going to talk to you about a couple of different topics. I'm going to cover upcoming hackathons that Algorand are sponsoring, and we want you to join and participate in. And Russ is going to close us out today on using the SDKs. They've been now updated to use the Algorand Virtual Machine 1.0. He's got some demos to show in making use of those SDKs. All right, Russ, welcome.
All right, go ahead and get going with this. So we're going to talk about using SDKs with Algorand AVM 1.0. A lot of how-tos here, all right? We're going to do a lot of how-tos in this session on how to use AVM from the SDKs. Maybe you want to know how to use program cost budgets, and maybe how to create a pooled group, or how to do inner transactions, or how to log from your smart contract. That's always useful. And then maybe just what's an AVM, right? So there's a lot of you that were brand new to this. We actually had a Dev Office Hours I can point you to that really goes to it in depth. It was a really great session. So just go out to the algorand.com developers/developer site, the one you use to sign up for this. Scroll down the page and you'll see this. Now, for those that, I'll give you a little recap from that and basically go over what it is. But basically we have here is that AVM introduces functions, looping, back jumps, recursion, right? Real programming language. It also increases the max programming size from 1 KB to 8 KB. And then combines state key value pair limits to give a 1 bytes total per pair. Also allows a contract composability via transaction group, shared scratch space, and provides newly created IDs, which is really big for ASA and smart contracts, prior to block inclusion via transaction group. Also, it enhances mathematical precision, 512 bits, and introduces additional math opcodes. Next, we have also enables fee-free transactions via transaction group, send algos and ASAs directly from smart contracts, and then also control escrow accounts directly from smart contracts, pool smart contract budgets, inner transactions, and new opcodes, including log support. Now, those last three is what we're going to be drilling into here today in this session on AVM using SDKs along the lines of pool, smart contract budget, inner transactions, and the log support. Just to give you a little bit more information on those three items, what we see here is you got an opcode budget of 700 opcode per call. Now, this can be pooled with up to 16 atomic application transactions. So if you take that 16, multiply it times 700, now your opcode budget is a little bit bigger, right, at 11,200. Also, you can see you've got 2K to 8K for both programs, the approval and clear. And then you also have some code there on the right that you can see, or on the bottom there, that you can see with creating a pooled group. We'll actually show you this in the code in a minute. And then we get to inner transactions, where you have up to 16 inner transactions per app call. Over on the right, you can see an example of that with some inner transactions. Those are all going to be used to build an asset. So that's going to create an asset. You can see you've got the type enum for the asset name, you've got for the create an asset, and then also have asset name, unit name, all the roles and so forth over here in the pie tail on the right. And then smart contract fees, pay fees for fees eligible for pooling, and fees are default minimum balance. Also shows up as inner transactions within the application transaction. And accounts can be rekeyed to smart contract, giving the spending authority to the contract, and the account must be in the accounts ready to spend from it, of course. And then supports all asset transactions as well as payment transactions. And logging, where you can see here an example, is what you have when you can go ahead and start writing out logs to the blockchain. And so it could be text or it could be numbers that you have in your arrays. All right. So the Python library, once again, those that are brand new to smart contract development, this is a really great way to build your teal. So on the left, you see the PyTeal, and then you can go ahead and generate the teal from that. Very good and easy way to generate a teal, very productive. Also, at the end, I got a little bonus for you. I just cover a little bit of debugging. I've done this once before, but I felt this was pretty good because you can actually step through all the teal, and I'll show you how to do this after the last demo. Basically, what you need to do is create a dry run requested with account, signed transactions, and your approval program source. And then you can go ahead and use the teal debugger, and that will show you as well toward the end here. And what that facilitates is doing and bringing up the Chrome inspect, and then you can step through every line of code and take a look at all the globals and locals and scratch space and stack and everything that's in there. Also, finally, there is a new call in the SDKs to get the address of an application. So you have the app ID, and this is what facilitates these calls to get the actual address for the smart contract. Now, why would you need that? Well, if you're doing a traditional like transaction, you have a from and to account, right? You need to have the account name or the address in order to do that. And that is what is provided there, is the actual address that's associated with that particular app. And there you can see examples in Java, JavaScript, Python, and Go. All right, so let's do some demos here. First one we're going to do is pooled groups, then we're going to do inter transactions and log support. And I really want to give a big shout out to Ben, our new member here on the DevRel team that Ryan introduced earlier here today. He created a lot of these demos here, and I'm just very thankful for him. And boy, these are really interesting and very cool. So let's go ahead and get started. We're just going to go fire this up, and I've got the sandbox running, and that's what I'm going to be pointing you to in the code. And what we're going to do here is get to a single transaction. So this is a pretty large transaction. If I take a look at what's going on here, if I take a look at the teal, this is the teal, the PyTeal that we use, and this is a pretty healthy call. It's expensive, on the expensive side. So this ED 25519 verify, and that's used to sign transactions. We're not actually going to sign transactions here, but we're going to use it for this demonstration of. And then the teal that this generates, you can see right here, and we have a link to all this code we'll be sharing with at the end. And then finally, we're back into our app. So the first one here, this we're going to run, and we're going to go ahead and broadcast it here. And this is going to go ahead and do our app call, which you take a look at that. That is just simply doing the application call method with all the parameters. And then what we'll see here is we'll go ahead and fire this transaction off. Now, down below, if you look down at the output, you can actually see here this dynamic cost budget was exceeded, and the remaining budget is we have 700 is what we start with, but the program cost is 1928. So what we're doing here is we're going to basically expand and create a pooled group with a few different calls. One is going to be to the original call. And then we also have two more. So now this would be plus 700 and plus 700. So now we're going to get 2100 in order to do that. And what we did is we dummied out the two arguments here that would normally be doing signs. And so it's just going to come in and it's going to go out saying, okay, you don't have any arguments. And life is good though, because what this does now is it extends the cost, right? That your budget that you have to stay within. And now this will go ahead and be a success. And there you can see the actual transaction was created. So some very cool stuff going on there. And then let's take a look at the next demo, which is going to be our inner transactions. So first, let's take a look at the teal. And this I had the slide on this with all the different addresses that are associated with managing callback reserve. This is basically just setting up an asset. And really what the inner transactions are doing is assigning properties, right, for each one of the method calls that are going to be used in the transaction. Prior to this, you had to load the whole transaction in teal. Now you can actually build the transactions in teal, and that's really an important thing to take away here. And we're going to start out with the global creator address. That's going to be the person that's creating it. And then we're going to go ahead and first check the sender if the app is indeed the creator. And seek is used to group a set of operations with only the last returning value on the stack. And then you go ahead and start building transaction builder right here with the begin. There we're going to go ahead and set our fields, and then we're going to go ahead and submit it. And then there you go with the approval teal that gets generated. Okay, so now let's go back over to the code. And let's go ahead and run this inner transaction demo. Now, this is all in Python. You have the same functionality in the other SDKs. I do want to point out a couple things as well. This wait for confirmation method now is built into the Python SDK. The other SDKs will follow. That's always been a chunk of code you had to copy and paste into your solution. Now that's going to be built right into the SDKs, and that's the method that will wait for the transaction to get written to the blockchain, so you get a confirmation on that when that's done. And then I showed you the ones that get the address for the user on that slide. All right, so we're going to go ahead and sign this transaction. You can see the here. This is in creating the app. And there's the account that we're using down below. That was the one that we used. Now we get into the meat of it. And this is actually going ahead and I created the application here, that create app method that we're just in. And now what I've got to do is, and I can see that the app ID down here is 33. And then we got the group transaction here. So we got to go ahead and get our group ID like we did before in the last demonstration. This time we're going to mix in a regular transfer of funds from the account into the one here that's being used. And then also we're going to call it with the inner transaction demo, that tool that we saw created. Now, this is another scenario that you can think of also like an escrow account. For example, this first one could be an escrow account that you are loading up from maybe a master account, or maybe like you got a payroll system and you have a master account with all the dough in it, right? And you're going to go ahead and create an account which is just going to accommodate the payroll. And so by the time you get done with that contract, that should be zero, right? That account should have a balance of zero. Everything has been paid out. So that's an example where you can also extend this kind of functionality for that scenario as well. And then also you have the signed group once again, and this is going to go through and sign each one of the ones that are in that transaction group. And then we're going to go ahead and fire off the send to network, wait for confirmation. And then you can see here, now we've got the assets being printed back as well down below, as you can see there for the particular asset ID number 36. So that's all the information there that you have and our example of inner transactions. And the final demo we'll go ahead and do here as far as the AVM 1.0 features. This one here, what we can do is take a look at the PyTail here. This is the logging one. So we have boilerplate, of course, at the very end here, and you can see where we're going to be. The no-op is the actual call, and that's where we're going to use this log, which we define right up here. And so now we're going to go ahead and iterate, right? So let's start at the top here. So we have our song, right? That's where 99 bottles of beer on the wall came in on our intro slide. And then we have, the lyrics, right, are going to be going down. I had a neighbor once who has since passed, and he really enjoyed this song. So I made a video of all these people doing this song, 99 bottles of beer. Came out pretty cool. So if you ever need a good gift idea for somebody, that's a good one to kind of do. All right. So anyway, here we have the scratch variable. We're going to go ahead and create for variable iteration. We're going to have a for loop, right? We're going to go through this thing, and we're going to start out at 99. We're not going to go down to 0. Okay. We value your time. So we're just going to go down to 97. That'll be a low one. And then we're going to go ahead and do our iteration, right? So that's going to be our loop. And then we're just going to go ahead and spit out that song, right, line by line as we go through it. So that's what you're going to see. And then, so the teal, we're actually going to step through this in the debugger in a minute after we get done running this. And so let's go ahead and take a look at what we got here in the code. All right, so as you've been seeing right along here, right now we've got our app call. We're going to go ahead and sign that in the sign group for that particular transaction. You can see we've got the dry run method. Let me actually step into that just so you can see what's going on there, because we're going to show that as well. And there's the, all right, I'm going to go ahead and here. So all we're going to do here is we're going to create, these are the sources that I had on the slide, right? So you got the application index, you've got the source that we're passing into this method right up here. So the signed transaction, you got the app ID, and you got the address. And then I'll come down over here and you can see you've got the accounts that it's going to do. And then this is where the dry run request is actually created. And this is going to be written out to the folder that you see. It ends with the .msgp in here. So let's go ahead and continue on doing that. And now we are running the application, and we should be able to go back to code. And there we go. And there's your 99 bottles of beer in the wall. 99 bottles of beer. Take one down, pass it around. 99 bottles of beer in the wall. All right, there we go. And that's 98 should be the last one after you pass it around. So anyway, that is the demos here on this. And the last thing we'll do here is I'm going to go into this one right here. So I have the teal debugger command is a command line tool. So we created that debugger file, and I'm going to go ahead and pass in the approved teal that we created as a source, and then the driver request that we created in that code. So we're just going to hit this, and now we can see we're ready to go. And I just need to go out to my target over here. Oh yeah, one other thing I got to do here, the sandbox. If you're doing it at this home, there are some conflicting ports. So I do down on the sandbox, and there you go. Magically, this comes up now. So we'll go ahead and do inspect, and then up comes the inspection. And you can see here, this is the boilerplate stuff that we started with. Let's go right down to our first breakpoint. So this is really great. You can actually set breakpoints in here. You can step through line by line, and then you also have all the information here set over here on the left, on the right, including the transaction information. We've got the stack, the scratch, and then the global variables there. So let's go ahead and just step over these, and there you can see now I got 99 went on to the stack. That's where we're going to be starting with. Also, we have that into this scratch space, and then this is going to be the end of the loop, which is going to be the 97. And then we're going to go ahead and branch to a call subroutine. So this is new right over here as well. So we're going to go ahead and execute that. So now we're down to sub 2. And now we're going to start the counter and get that to run. And then there's the first line, right? 99 bottles of beer on the wall just got executed. And then we'll go ahead and hit this and just go right down to the next step here, which is where you see all of the text that gets written out from the application. So that's just give you an idea of the debugging capabilities. We saw 3 different demos here. The first one was pooling a smart contract budget. So this really helps you determine the opcode expense and then also facilitate how to expand that programmatically, like you just saw in the demo here today. Inner transactions is great. This is really great because now you can build ASAs right on in teal. And this helps facilitate that. An example we saw, we had used different asset properties that we need to send when we go ahead and create a brand new asset. And then finally, there's 15 new opcodes, one of which is we just saw was the log support with the log command. And then also a lot of great resources here to go with you. If you have not joined Discord, now is the time to do it.
Russ, you had lots of great things in there. That was a lot of fun. Going through all of those different scenarios really in a succinct way really showed us what are the new components that the AVM 1.0 introduces, how do we use them, how do we access them within the SDKs. So thank you for your time on that. Definitely make sure that you are reaching out to us on Discord. Russ recently put the link there. We've got channels for everything there. We want to make sure that you get your questions answered. All right, I'm going to attempt to share my screen and kick us off with a couple of hackathons that we have got. Algorand Innovate. So this hackathon just started last week. Registrations are now open. What's super exciting about this one is prizes. Let's just focus on that. We've got 100,000 in prizes available for this one. So we've got the grand prize going for 40,000 USDC.
Woohoo!
And no slouch. Even if you finish in second or third place, we've got 20 and 10,000 all the way down. We have different themes here. So the way this is organized is you're going to choose a specific theme that you want to compete in, and then you can compete to win within that discipline, and then everybody competes for the overall winner as well. So we have an open theme where you can basically do anything that you want, something that doesn't fit into the other 2 themes. So let me just go to the specific themes here. So we've got one on FutureFi, right? The future of finance, right? Algorand always likes to say that we are ready for you to build FutureFi with. Some examples that you might see here would be geared towards financial applications such as lending, exchanges, derivatives, permissionless, open source. Make sure that it's permissionless, open source. Anybody can build on top of these projects. Another example would be decentralized governance. Anything where you would be having the decisions and the administrative privileges not being held by a single entity. right? So that you could think of something that is helping in fintech or in DeFi or in anything that has to do with FutureFi. All right, so that's one of the tracks. You can read a little bit more specifically there. The other one would be digital art and collectibles. Some people might just say that's NFTs, right? Generally speaking, if you're thinking about you've got something that you want to do with NFTs or anything that is digital arts related, we've got a track for that. Music, video, copywriting stuff, whatever you want to do. You can use your integrations with the IPFS file system or any other decentralized file system, or you can do it centralized. It doesn't matter how you design your solution, but it would be something focused on digital arts. And then I'll go back up here to the open one. So the open one is something that doesn't fit into either one of those other solutions. So we've got a couple of examples here. Building a decentralized naming service that would match, say, the address to a simple name so that you could send to a name, rather than sending to the Algorand address, but behind the scenes, that would be linked up together so that obviously the transactions on the network are going to the address, or perhaps build a blockchain-based game or a decentralized autonomous organization, or simply converting any existing Web 2.0 application into a Web 3.0 dApp. So thinking about any of your simple games on mobile that you'd like to play with and have your idle time going, convert those into a blockchain-based gaming experience, and that would fit into the open theme here. So this, once again, is Algorand Innovate. You can get there by going to algorand-innovate.hackerearth.com. So you will be required to sign up under Hacker Earth, create an account there, register now. It's open to start, and this is a long-running hackathon. It ends the second week of January, so we've got lots of time to design, develop, and work on your hackathon there and get it ready for us. This is an Algorand-specific one, and we've got huge prizes. Go there now, algorand-innovate.hackerearth.com. Next one I want to talk to you about is one that is also ongoing. It actually just launched on Friday. This is SB Hack 21, or the Swiss Blockchain Hackathon, happening on DevPost. So if you go to sbhack21.devpost.com, you will come here, and again, you can sign up for this one. It's already started. It's an online and an in-person hackathon, meaning that the hackathon is open right now. It closes on Sunday 31. This is happening on site the last weekend of this month in October in Zurich. So I'll be there to work with the on-site hackers, and they get a limited amount of time. They've only got 3 days, really, Friday, Saturday, and Sunday, to get their hacks going and ready for judging on Sunday, the 31st. So you guys are at an advantage. Sign up now and take a look at the challenges that they have. I'll come back to those, but let me just show you here. They've got some huge prizes as well. They've got over $1/3 worth of prizes available. They come down here. So here are the prizes, right? So if you are building on Algorand specifically, we are handing out 8,000 USD to the winners and 20,000 in total for the top 4 prizes building on Algorand. Plus, the teams are also eligible for the overall, right? So the Swiss Blockchain in a Booster Accelerator program is also something, is a prize here. So if your team of up to 5 are winning, or one of the top 10 teams here, you would also be eligible to participate in a comprehensive six-week coaching program and accelerator program as well. So let's take a look at some of the challenges that they have available. Seba Bank is focused on DeFi. They have a challenge where they've got a couple of different ones, but they're looking for, let's see, the scope of this challenge is design a protocol which can be attractive for institutions and other regulated players, deliver a proof of concept for a platform and technology feasible plan for completing the development, focus on the features and the place for making an attractive regulated entities. All right, that doesn't sound all that exciting, but trust me, they've got some interesting things. All of these have the YouTube videos where the sponsors are explaining what they are, what they want to do with their ones. So I want you to take a look at these. I'm not going to go in and play them because, well, let's face it, they just don't play very well over streaming. Here's one focused on fake news. This is interesting. How do you identify fake news, and how can we use the blockchain to make sure that this is from a trusted source? Let's see here, the smart contract for factory logistics. I think this one has to do with supply chain and using timestamps and smart devices in order to have supply chain tracked using the blockchain. Smart assembly solutions, same sponsor there, similar. Food, this sponsor here working with cheese and how they are tracking the ingredients and from the farmers all the way to the consumer. This is an interesting one for you gamers out there. So Dex Game, they want you to build a gaming solution, a gaming platform. So working with tokens that would represent in-game assets, making a marketplace for exchange of those, and also tracking player points, player match outcomes, and so on with a blockchain. For gamers, this is a pretty cool challenge here for sure. Another gamification one. I'll have to let you read that one. There's another one. There's one that's an NFT challenge. Maybe it was the very first one, and I skipped over it. All right. The point being that we have here, I think there's about 15 different challenges that are available here. Each of the sponsors have up to 10,000 in prizes for answering their specific challenge, and then as well as if you are building it on top of Algorand, then you are eligible fitting it on top of or getting the prizes for us as well. Yeah, this is the one. Seba Bank and Loomis, they are looking for an NFT marketplace. And I gave the welcome introduction to this group the other day, and I picked this one out specifically and said, if you go to the developer.algorand.org website, our developer portal, right, and you go to the Learning PyTeal example with Alice and Bob, this is the exact challenge that they're asking for right here, which is to build an NFT marketplace. And at our developer portal, smart contracts and dApps, building with Python, right? This example right here, after you spin up the sandbox and you come down here, you meet Alice and Bob. And Alice is a creator, and she wants to be able to take her token, or I'm sorry, take her digital artwork, turn it into an NFT token, and she's going to work with buddy Bob, who is a smart contract developer, and he's going to help her then put it into a marketplace, and they go through all the code right here. So that is exactly what Seba Bank and Loomis are asking for in theirs. So go ahead and build that. You can learn it, how to do it right here on the developer portal, and at the same time be competing with others on how to do that. All right, generative art NFT things, so making something that creates or evolves the NFTs. Lots of fun things. All right, the last thing that I want to make you guys aware of is, since so Russ is going to come up next and talk to us about the SDKs and the addition of the AVM components into our SDKs. So we have at GitHub, as you probably know, we have these bounties, a whole bunch of bounties that are available for our community to go and ask or to answer. So we've got them for the important one that I want us to focus on here is this one. So updating our community SDKs to support AVM 1.0. All right, so this would be like we have community provided SDKs in C# and Swift, and there's quite a long tail of
Flutter
them.
and
yeah. So we Algorand have already updated these for Go, Python, Java, and JavaScript, and this is all about answering it for the other community-provided SDKs. So adding in AVM 1.0 support for those. And we've got a bounty here of up to 1,000 algo tokens for doing that. So take a look at Gitcoin, or to search for that on Gitcoin and find one of those. All right, take care, everybody. We'll see you on another episode of Developer Office Hours in a future week. Thanks again.